We now discuss the solution of a problem from the section Vector Algebra. The given question is about the vectors of the diagonals of a given parallelogram. This question has appeared in the joint entrance examination main held on 27th June 2022 in the second shift. The given question is, let A and B be the vectors along the diagonals of a parallelogram having area 2 root 2. Let the angle between A and B be acute. Mod A, length of the vector A, is equal to 1, and mod of A dot B is equal to mod of A cross B if C is a vector given by 2 root 2 multiplied by A cross B minus 2B, then an angle between B and C is, we are given 4 options. Option A, pi by 4. Option B, minus pi by 4. Option C, 5 pi by 6. Option D, 3 pi by 4. Okay, we have a parallelogram and its area is 2 root 2, and these vectors A and B are along the diagonals of this parallelogram, and the angle between A and B is acute, and the length of the vector A is equal to 1, mod of A is 1, and mod of A dot B is equal to mod of A cross B. If C is a vector given by 2 root 2 multiplied by A cross B minus 2B, then required to find the angle between B and this vector C. And then you have to find an angle between B and C. That means you have to choose an angle from these 4 options. Agreed. That is the given question to us. We now discuss the solution of the problem in detail. We have a parallelogram P with area 2 root 2. This is the parallelogram P whose area is 2 root 2. Given A and B are the vectors along the diagonals of P, and the angle between A and B is acute. This is your A along one diagonal, P, the vector B, along the other diagonal. And you are given the angle between A and B is acute. The angle between A and B is theta, and theta is acute. Agreed. Further, we are given mod of A is 1 and mod of A dot B is equal to mod of A cross B. Agreed. Now, we use this fact. The area of the parallelogram is 2 root 2. The formula for the area of the parallelogram is half into modulus of the cross product of the vectors along the diagonals. That is 1 by 2 mod of A cross B. Then this will imply mod of A cross B is equal to, send this 2 to that side, 4 root 2. Let's call this relation as 1. And mod of A cross B, that is mod A into mod B into sine theta, is equal to 4 root 2. One may ask a question, sir, there is a modulus, mod sine theta you have to write. Yes, you are right. But theta is given to be acute, Therefore, mod sin theta is same as sin theta. Agreed. Agreed. And mod of A is given to be 1. So substitute, that is equal to, where theta is the angle between A and B, which we have already shown in the figure. So mod A is 1. Therefore, mod B sin theta is equal to 4 root 2. And that is the relation 2, second relation. We use the other fact, that is modulus of A dot B is equal to modulus of A cross B. And this will be mod A into mod B into cos theta is equal to mod A into mod B into sin theta. Modulus for cos theta and sin theta we have not kept because theta is acute. Mod cos theta is same as cos theta, mod sin theta is same as sin theta. Agreed. So cancellations take place and we will get sin theta by cos theta is equal to 1, that is tan theta is equal to 1. That is, because theta is acute, theta is equal to pi by 4. Agreed. Agreed. Now, from 2, second relation, mod B sin theta is equal to 4 root 2. So, mod B sin theta, and theta is pi by 4. Sin theta sin pi by 4 is 1 by root 2. That is, mod B into 1 by root 2 is equal to 4 root 2. That will imply modulus of this vector B, the length of the vector B, is equal to 8. That is the relation 3. We continue in the next slide. We want these results. Modulus of A cross B is equal to 4 root 2, that is the relation 1. Mod B is equal to 8, that is the relation 3. And we are given another vector C, which is given as 2 root 2 into A cross B minus 2B. And our goal is to find the angle between B and this vector C. This vector C. So why not we call the angle between B and C as the angle alpha? Agreed. So we take C, take the dot product with B on both sides. So we'll get to C dot B is equal to 2 root 2 A cross B minus 2B in brackets dot B. Now use the distributula, we'll get 2 root 2 into A cross B dot B minus 2B dot B. Now look at A cross B dot B. What is this? This is a scalar triple product of the vectors A, B, B. In this scalar product, what we see is two vectors are same. And in the case of the scalar triple product, if two vectors are same, then it will be 0. It will be 0. So A cross B dot B is 0. And this will be 2 minus 2 into B dot B is mod B square. Minus 2 B dot B is minus 2 into mod B square, length of the B square. Agreed. On the other hand, you take C dot B and write mod C into mod B into cos alpha. Alright, here minus 2 into mod B square. So mod B is 8. Mod B is 8. Minus 2 into 8 square, that is minus 128. So right, now on the other hand, C dot B is mod C into mod B into cos alpha. There is no modulus here, so cos alpha, just cos alpha. And we have C dot B on the other hand, it is minus 128. And on the mod C into mod B into cos alpha, mod C into mod B is 8 mod C cos alpha. C dot B on the other hand, it is minus 128. So therefore, 8 into mod C cos alpha is equal to minus 128, and mod C into cos alpha is equal to minus 128 by 8, that is minus 16. Call this relation as relation 4. So if we know modulus of C, we will get cos alpha, and thereby the angle alpha can be found out. That's the angle between B and C, that is the alpha, can be found out. So what is our goal? Our goal is to find modulus of C. So take the C, and modulus of C square is equal to C dot C. Right. And for C you write 2 root 2 multiplied by A cross B minus 2B dot the same vector, C dot C. Now multiply 2 root 2 A cross B dot 2 root 2 A cross B is 2 root 2 into 2 root 2 is 8. A cross B dot A cross B is mod A cross B square. And minus into minus plus 2b dot 2b, that is 4, b dot b is mod b square. So what happened for the other two products, like A cross B dot B, that is 0. And B dot A cross B, that's also 0. So therefore you get this one. And you know mod of A cross B is 4 root 2, that is 8 into 4 root 2 square plus 4 into mod B square, that is 8 square. And simplify, you will get 2 into 256. So that is your mod C square. So what will be mod C? Mod C will be under the square root of 2 into 256, that is 16 root 2. Agreed. We will go back to relation 4, and from the relation 4, mod C cos alpha is equal to minus 16. Cos alpha is equal to minus 16 by mod C, that is 16 root 2, and when simplified you will get minus 1 by root 2. Let's look at our options. So cos alpha is minus 1 by root 2 only for alpha is equal to 3 pi by 4, but not for any of them, any of the other angles. So cos alpha is equal to minus 1 by root 2. From the options, alpha will be 3 pi by 4. So the answer is option D. So that is the detailed discussion of the solution of the problem from vector algebra, and I am sure that you have understood the solution of this problem, and I wish you all the best. Thank you.